So this is a sort of an introduction to planes. It's for some reason it's really confusing to people. What exactly is a plane? So hopefully this can clear some things up. A plane is a two-dimensional, it's a flat surface that extends infinitely in all directions. So a lot of times you'll see a plane, and maybe I'll try to make this straight. You'll see a plane drawn like this, pretend that the ends connect. And while, it's usually represented like this, it's not actually true because the plane does not end here. It'll keep going forever and ever and ever, but it is two-dimensional. It doesn't curve at all. It has no thickness. It just has two dimensions. The width and I guess you can't really dimension them because it's infinite. But, they only exist. It only exists in these two dimensions. So what defines a plane? One common way to define a plane, and in fact, this is actually how we name planes, is if you have a plane. Let me just draw another one here quickly. If you have a plane, it can be defined by 3 points on it, as long as they aren't on the same line. So, like for example, if we had point A, point B, and point C, and as you can see, they don't. If you connect these dots, it doesn't form a straight line. Well, we can call this plane right here, we can call it plane ABC. Because there is only one plane that passes through all three of those points. We can't have a plane that looks something like that and goes through B and goes through those 2 points because it doesn't go through A. So plane ABC has to be that one plane that I drew right there. So why can't a plane be defined by 3 points that are on the same line? Well, let's take a look at these points, which we'll call D, E, F, and let's say these points are collinear, meaning that they're on the same line. Well, yes, a plane could be like this and have all 3 points on it, but the plane could also look like this, right? And this, if we filled in this plane right here, this plane would intersect the plane we drew earlier at this line. And so this plane would also have points D, E, and F. And that's why one line cannot define a plane. If you have, let me do this in a different color. If you have one line like this, well, there are an infinite amount of planes that can be drawn that go through that line, right? Because we have this one here. If we had another plane this way, I'm pretty bad at drawing this stuff, but we could have another plane that goes through it like here, right? Just imagine if we have a plane on a line, imagine taking this plane and just rotating it, spinning it around this line. Imagine this line as a sort of, I don't know, like an axis of rotation, and you can spin this plane around that line 360 degrees. And so in every place you can spin that plane in every new position, well, that's another plane that goes through that line. So that's why we cannot define a plane by a line or 3 points that are collinear. It has to be defined by 3 points that are not collinear. Another way you can define a plane, which is very similar to this, is 2 vectors. As long as the vectors aren't the same vector and they're not opposite to each other, because again, 2 vectors that are opposite each other, wow, well that looks awfully lot like a line, doesn't it? But if we have 2 vectors, if you have 2 vectors that are not, either the same vector or 180 degrees rotated, well, now there's only one plane that can go through both of these vectors. There's just one. And you can kind of see that here. These 2 points, you can draw vectors connecting these 2 points, right? Either from A or from B or anything like that. So 2 vectors that satisfy the criteria I just mentioned, those also form a plane. Another important thing to note is, as you can see here, 2 planes that intersect will always intersect at a line unless they're the same plane, right? Like if I have a plane right here, this is my plane, and I have another plane, let's do this in blue. Here, these planes are going to be intersecting. Yeah, it looks like they're going over all of this, but let's pretend they're in 3D. They'll be intersecting at one line. However, if they are the same exact plane, and remember, since they don't have width, since planes don't have width, technically it is possible for them to, just be like that. It's not really on top of each other or below each other because, they don't have width. But if they're the same plane, then both of those will continue infinitely in all directions, and so that those planes will intersect at an infinite amount of points, everywhere. So that doesn't count. But if the planes are not the same plane and they intersect, they will intersect at a line. But if the planes do not intersect ever, that means they're parallel, right? Same thing with lines. If you have two lines that never intersect, and I understand that these are not lines even, but if you do have two lines that never intersect, those have to be parallel lines because they go on forever. Same idea with planes. The only way a plane cannot intersect another plane is if it is parallel to it. A lot of this is pretty, intuitive, like, the fact that planes have an infinite amount of points on them. Well, of course, if they extend infinitely, there's an infinite amount of points. And stuff like, oh, well, if a plane is two planes are perpendicular to the same plane, then those planes are parallel. Like, yes, that just makes sense. And if something like that, you see a question like that or some language like that, for me, it always helps to draw it out. Draw out your planes, try to really understand what they're trying to say, because it'll sound confusing, but when you draw it out, everything will make a lot more sense. So, this is your basic plane. One more thing I do want to mention is a lot of times people will say stuff like, if you have a cube, the faces of this cube are planes. The faces of this cube are not actually planes. Why? Because they don't extend infinitely, right? It's just a portion of a plane. Yes, they're flat and the faces are two-dimensional, but they're just portions of a plane. Okay, just remember, those aren't actual planes. They're portions of a plane. They're flat two-dimensional surfaces, but it's technically not correct to call it a plane. What you can say is that the faces of the cubes are on a plane. They rest on a plane, because you could technically extend, pretend it's on the same thing. You could extend this forever, right? And you can say this face is on that plane, which you might actually see when you do like engineering software and stuff. You'll be making shapes on that plane, but it's technically not a plane itself because it doesn't extend infinitely.